Hi everyone, and welcome to week 13. We've already taken a look at the way that the quantifiers work, and we've so far been considering sentences in which there's just one quantifier. Sentences like every Dalmatian is a dog, or all dogs are mammals. But now let's take a look at what happens when we multiply quantify sentences, that is to say when we have more than one quantificational sign. We're going to kick this off by looking first at sentences with multiples of only one type of quantifier, unmixed. So multiple universal quantifiers and multiple existential quantifiers, but separated out. We're going to see how these work. For the most part, it's pretty straightforward, except for the crucial point that we have to remember that variables range over all objects in the domain of discourse, and as a result, multiple variables can range over the same objects. We'll soon see what I mean by this. Well, now it's time to look at what happens with multiple quantifiers in the same sentence. For example, consider the following. What this sentence says is that something is a dog. I've color-coded the variables here so we can just see the structure a little more clearly. And that something is a cat, and the dog, the X, is larger than the cat. So in all, this is equivalent with the English sentence, some dog is larger than some cat. So here we have two different quantifiers, but unmixed ones. They're both existential quantifiers. And they're both out front here, which is what we call prenex form. It might look a little more natural to write it like the following, which is logically equivalent. So what we have here is the equivalent statement that something is a dog, and something is a cat, and the thing that's a dog is larger than the cat. So these are equivalent, and this one just shows us the structure, and it's different from the prenex form up here. Similar observations apply to sentences with multiple universal quantifiers. Let's turn to those now. Suppose that we wanted to translate in the other direction, and we had a sentence like, every dog is larger than every cat. Well, we can see that we have here two quantifier terms, so we're going to want to set those up front, at least for our prenex form. And we've seen already that universal statements have to be translated as conditionals on FOL. So we'll say, if X is a dog and Y is a cat, then X is larger than Y. Again, if we wanted to write it otherwise, the way we did with the first one, we would just push the other quantifier inside. It's fine because it's still within the scope of the first. So now you might wonder why it is that we write a conjunction up here but a conditional sign down here. Why not just write it in the following way? What this ends up saying though is that everything is a dog and is larger than every cat. And that's not right. Not everything's a dog. Actually, this whole sentence comes out false. So it's important to be very careful in thinking about exactly what these FOL translated sentences with multiple quantifiers mean, and we're going to see far more examples of this in the upcoming videos. I just want to conclude with a point about variables which leads to confusion even for those of us in the biz, and this is the following. Distinct variables do not necessarily range over distinct objects. Here's an example of what I mean. Suppose your domain of discourse is just this strip of sidewalk that's 2 blocks wide, and on these 2 blocks there are 2 cats. We might be tempted to say that for every cat X and for every cat Y, these cats are either left of each other or right of. But in fact, this sentence is false. Granted, the cat on the left is left of the cat on the right, and the cat on the right is right of the cat on the left. But these two variables here, X and Y, don't pick out different cats, and so they both range over the left cat and over the right cat. What this in effect means is that every cat is either left of or right of every cat, and that requires then that this cat be left of itself or right of itself, and that this cat be left of itself or right of itself, and that can't be because nothing can be to the left of itself or to the right of itself. So we have to be very careful about assuming that our variables range over distinct objects. It's tricky business. If you wanted to say that every cat was to the left of or to the right of every other cat, you'd have to use our do not equals sign. So you would say, for every X and for every Y, if X is a cat and Y is a cat and X does not equal Y, then, and you would just add in here the rest of the formula. And this, for our little sidewalk domain, will come out true. So you have to be very careful with distinct variables and assuming that they range over distinct objects when they really don't, and you have to keep your eye out for this does not equal sign to tell you that we're dealing with multiple discrete objects here. I'll give one more example before we conclude. Take an existentially quantified sentence that expresses something like the following. Something stands in the P relation to itself. Suppose that we take this to be our identity predicate, then it's going to be true, in which case we'll write it like this. So something is equal to itself. But here's the interesting thing. This actually implies there exists an X and there exists a Y, and X is equal to Y. Of course, the implication doesn't work in the other way for every predicate. So clearly then, although we have discrete variables, we're not talking about discrete objects. In this case, the implication would work the other way, but in some cases, it doesn't. For example, consider someone sees themselves. This implies someone sees something, but of course, just because someone sees something doesn't mean someone sees themselves. The main point, though, is just to be careful about distinct variables and not to let them hoodwink you into thinking that they're ranging over discrete objects.